In the previous video, we ran our first training iteration and created a run in 3LC, used the dashboard and embeddings to label a batch of unlabeled samples, reran training with the updated tables, and submitted our predictions to Kaggle. This video is about the weighting strategy, and it will help you get the most out of your labeled samples. I'll explain what happens when you set the weight to 0, 1 or higher and how that affects training. Then we'll do a practical strategy, which is to find low confidence images in your labeled pool, which are the ones our model gets wrong or is unsure about, increase their weights so the model sees them more often and pays more attention to them during training. That way we extract most from the labels that we already have without adding new ones. In 3LC, each and every row in your train table has a sample weight, and that is the number that controls whether and how much that sample is used in training. When the weight of the sample is set to 0, that sample is excluded from training. This is why undefined samples don't affect training until you label them and change their weight to 1. When the sample has a weight of 1, it is included normally. That means it's in the training set and it counts like any other labeled sample. When the weight is greater than 1, you're essentially telling the model to pay more attention to that sample. So a higher weight means the model sees it more times per epoch. Either way, increasing the weight on certain images makes the model focus more on them during training. So let's go ahead and inspect one of our training runs and try to implement this strategy. Now, before we change the weights of our examples, to keep it simple, you can first label as many undefined samples using the embeddings and later use the strategy to maximize performance. Now let's go ahead and first create a 3D chart of the embeddings as always. Then we want to create a 2D chart of the image and the label column. And then we want to filter out the defined samples from the undefined samples. So let's go ahead and check out these two boxes. Now we want to find out the low confidence images, and to do that, let's drag over the confidence column over where it is written label in the embeddings chart. And we can see a few samples over here which are really low confidence. Let's go ahead or either use the lasso tool or just the confidence filter on the left hand side to get a few candidates. And from the given ones, we want to first of all make sure that these are labeled properly, because if they are not, then we will end up inducing biases into our data set. So this is a Chihuahua. These ones are true. This one is not. So now we want to change this from Chihuahua to Muffin. Do that. Let's go over and see the other ones. This is a Chihuahua, that's right. Muffin, Muffin, Muffin. Okay, this is a wrong one. So let's go ahead and change it to Chihuahua. Let's go ahead. This is a Chihuahua as well. Same here. These are muffins. And now we have made sure that the images have the right labels. We want to then go ahead and shift click the first sample and shift click the last sample. And then we can go ahead and change the weight from 1 to 1.2, for example, and commit the pending edits. Now what this is going to do is create a new table revision with our updated changes. Let's go ahead and start our training. And in the meantime, I can show you the updated table. And here you can clearly see that our updated table is showing up. Let's go back to training. And it should be very fast. Essentially what we're trying to do is take these hard samples and exposing them more to the model so that it can learn them well. As you can clearly see, After the training is over, we have a slight improvement on our score. And this is exactly what I wanted to show you. Use this strategy after you've already labeled a good chunk of the undefined pool and have a decent sized label set. First, get more labels from the undefined set using embeddings, and then once that's exhausted or you want to refine further, use weighting on the labeled pool to focus on low confidence or high loss samples. That way you're not wasting capacity on easy examples, you're teaching them all to fix its own mistake on the hard ones. So to finish this up, let's go ahead and run the prediction script to get a submission CSV that we're going to upload on Kaggle and get our updated scores. Now let's take the submission CSV and head over to Kaggle, our folder, and make a submission. As you can see, we got a really good score on Kaggle and our validation accuracy has generalized well to the test set. That's a result of the data-centric AI approaches we've taken so far, including embedding-based analysis, using model feedback to label samples from the undefined pool, and then weighting strategies to get the most from our label data by having the model focus on hard samples. One important caveat, we have to be really careful with weighting, because overweighting or weighting the wrong samples can induce bias in your model, and the validation accuracy may not transfer as well to the test score that you get on Kaggle. So weighting thoughtfully and keeping an eye on both while and test metrics is really important. Finally, one important thing that I wanted to show before ending this video series, if you are on a selected run and if you press the button P on your keyboard, you head over to this details panel. So this is a really useful feature on the dashboard. You'll be able to see the selected runs and where it's located locally. You can see the input tables. These are important as it lists the exact table versions that were used as input for this run. So when we applied weighting, for example, we saved a table like plain table weighted. You can confirm right here that this run actually used the weighted table. That's how you verify that your data-centric changes were actually made into the training run. You can also switch between the input table revisions if you have several to compare how different data versions affected the run. So for example, if we went back to training table 3, we can see that we did not have any weighted samples. But if, for example, we went back to the weighted one, if we scroll here, we would then go and get the ones that we weighted up. So that's it. And if you have any questions regarding anything we've covered so far, please head over to our Discord and ask them. We'll get back to you as soon as we can. Good luck in the competition and may the best data wins.